Yeah, you playing the game?
Yeah.
All right, I see now.
Okay, so get this. This is like literally the start of the game, so it's really cool. You can take these markers and just start writing stuff on the
Oh
windows.
wow, okay.
So just a random little thing the devs added in, but I could use it to like draw stuff. I just need to make sure not to drop these because I found out the hardware earlier. I can't reach down to the ground. So all right, I'm gonna shift over here. The view's probably gonna look a little weird for a second because I gotta reach over to my laptop and lesson two. So lesson two covers a lot of vectors. And it's going to ask you stuff with both vectors and scalars. So scalars are basically anything where it's just a simple value, like say like volts, amps, any kind of a number that represents some quantity. Vector is basically a magnitude with a direction. So like, say I drew a line and it's just like, I don't know, 10 units long. That'd be scalar. But if I gave it, say, a direction along with that, then that's effectively a vector. It's some sort of magnitude with a direction. And that's basically your first question.
Okay, so could you run horizontally, or you would be inclining, or you could decline as well?
Yes. Yeah, it could be any kind of direction. It could be two-dimensional. It could be even three-dimensional. So like one good example of a scalar would be like, say there's like a sign that says like 5 miles, but if you had a sign that said 5 miles and it pointed in a direction, that would be a vector.
Okay.
And then another example, and this is the only one that I got wrong on the homework for lesson 2. Another good example of a vector would be, say, a 20-pound weight, like 20 pounds of weight. You've got a magnitude, and you've also got the direction. Because it's got weight, it would go down. So that's basically the difference between vector and scalar. And then there's, I don't know the significance of this one part, but there's one question that asks you what the two endpoints are of a vector. So I'm just going to redraw this here. So the starting point of your vector, that's just called your initial. And the endpoint over here is your terminal. Oh god, I'm terrible with writing with these. You got that down though, right?
Yeah, I'm writing it.
Okay. And then I'm gonna go ahead and make a very, very crude graph on the window here. Okay. Alright, so this is my graph. I'm just gonna make a few notches. I should probably just try to do as much as I can without going directly back to the
Alright.
web page because it's gonna take a bit of time. So there's gonna be a few problems on the quiz where you're gonna have a graph like so. You've got your X, you've got your Y, and what's gonna happen is it's gonna have several, like usually 2 different vectors on there. So you could have one that would be going from here to like say here, and then maybe you might have another one that's over here going down to like there. And it's going to ask you like what are the initial terminals of these vectors. So this one, for instance, you'd have an initial of 0, 0,
Okay.
and a terminal of, and you basically just give the x and y of each one. So like this one would have an initial of 0, 0, and then it would have a terminal of 1, 2, about 3 for x, and then 3 for y. Looking at this graph here, and then for this other one, you'd have an initial of about -4 for x, +2 for y, and then a terminal of -2, -2 for the terminal. So it's kind of straightforward, and they might ask you to do it in, I think they called it composite form or something like that. And it's basically just asking you to write it in a form where you just write it, instead of giving the start and end points and coordinates, you just basically list the x and y in terms of their actual length. So this one would have a length of 3, so you'd write it as x3 and it's got 3 for y in terms of height. And it would be positive if it's going to the right, negative if it's going to the left. So like this one, for instance, it would be, let's see, it's got a horizontal of 2. So x of 2. And for this one, the y is going down, so it's down 1, 2, 3. So that's got a y of -4, and that's probably like the first quarter of the entire assignment. There is just a lot of questions like that.
Okay, that makes sense.
It's pretty straightforward. Once you get to the next couple, though, is it okay if I erase this?
Yes.
Okay, cool. Next couple, you have to use like 2 or 3 formulas, but it's nothing too complicated. I'm just going to do as much as I can from memory without pulling it up. There's going to be a couple others where it's going to ask you to add the vectors together. So you might have something where you've got a vector that's going in this direction and it's got a value of, say, like 10, and they want you to add another vector that's going literally the opposite direction, and it's
so you just subtract those, right?
Yeah, you literally just subtract it, and so your end result. And by the way, they call this the resultant. Whenever you add any kinds of vectors together, that's what you call your resultant.
All right.
Is the addition of the two. So it's really straightforward for that part, at least. If it's just 2 vectors and they're going in the same or opposite directions, it's super straightforward. But then they're gonna throw some at you where you've got 2 different vectors and they're going in completely different directions, and that's where you have to pull up a couple of formulas. There's like, I think 3. I'm gonna shift over to my laptop real quick. Okay, let's see. Let's see what was on 4 again. Good for 4. Let me check 5. Oh, right. So the when I had that graph up, and there was that one vector that was starting literally like dead center of the graph.
Right.
That's called standard position.
Okay.
I don't know if you'll ever need to know that aside from the homework assignment, but something you'll need to know. Let's see. It should be good for 7. Let me see what was on 10. That's good. Let me check 11. Right, so another little thing, if you ever have to rotate a vector, I've only seen this for just this one homework assignment so far, but you're gonna have 4 different lines that are gonna be pointing in different directions, and it's basically just telling you to give the angle that each of those lines are pointing in. So basically, for the angles of a vector, vector pointing directly to the right is 0 degrees,
All right.
and increasing degrees goes counterclockwise. Specifically, not clockwise. But there's one where you'll have to literally just match up the degrees with the lines. It's pretty straightforward.
Yeah.
Get my marker back up here. Okay, so you're gonna have a couple problems where you've got triangle, like so. You've got your angle theta. And let me take a look at, see what those lengths are. 20, 16, and 12. Okay. So you've got a length of 20 on this side, a length of 16 on the adjacent, 12 on the opposite. Oh, jeez. This is a little stuttery. It's just barely enough for me to do it accurately. Okay, so you're gonna have this for a couple of questions, and it's basically gonna ask you like what the sine and what the cosine is of the angle. This one isn't too difficult if you can remember a little something from geometry class if you ever took it. Which is... Okay, right there. I'm just gonna do this here. So you may have heard of the little phrase in one of your old math classes called SOHCAHTOA. This is probably something you'll want to write down. So basically, if you want the sine of an angle, take the opposite.
The opposite over hypotenuse.
Yes, opposite over the hypotenuse. And then if you want the cosine, it's the adjacent over the hypotenuse, yeah. And you'll have a couple questions where you'll need to use this, and then if you need the tangent of an angle, you just take the opposite and divide it by the adjacent. So the one that I picked, for example, it just wanted the sine of angle theta, so you'd literally just take opposite, so opposite over the hypotenuse, so 12 over 20, so it's just 0.6. Like, it's, that one's super straightforward as long as you remember these, which you should probably know down, unless you know them by heart.
No, I don't know him by heart. I have to write him down.
Okay, go ahead and write that down. I'll just keep looking at it for a second here.
Yeah, I wrote him down. I got him already.
Okay, cool.
Yeah.
I don't know if you're seeing this on the stream, but it's the frame rate's like kind of glitchy for me.
It's a little glitchy, but it's definitely not as bad as today's class.
Okay, cool. Yeah, it looks like my screen's having a seizure right now. Here, let me check the next one. I don't think I need that anymore, but let me check and see what the next problem is. So you're gonna run into a couple of questions where you're gonna have a vector and it's gonna go at some weird angle and it's gonna have a specific magnitude, and it's gonna ask you to get either the horizontal or the vertical value of it. And
Okay.
two specific equations for that. So if you want to get the horizontal, Oh boy. One second. It's gonna be a little awkward. Can I do that? No, I can't. It's unfortunate. Okay, so if you want the horizontal, take the length of your vector, and you multiply that by the cosine of your angle theta. And then if you want the vertical, take the length and you just multiply it by the sine of the angle for that one. A couple questions where you're also going to need to find specifically the angle, your angle theta, and there's one equation for that, which is the inverse tangent vertical divided by your horizontal value. So let's suppose you've got one vector. Let's just assume that's 30 degrees. And it's got a magnitude of, say, 5. And you've got another vector going up at 90 degrees. And it's got a magnitude of, I don't know, 6. Oh, crap. And it's going to ask you to get the resultant of the two. So what you would do for that is you utilize these two formulas first for each of your vectors. And do you have a calculator handy?
Yes, I do.
Okay, cool. Okay, so do me a favor. Get the sine of 30 degrees, multiply that by 5.
Sine of 30 by 5?
Yeah, sine of 30 by 5. We're going to get the horizontal of this one.
And that's 2.5.
2.5?
Yeah, 2.5.
Okay, 2.5. So this one here, you know, the height value starting from here up to there, it's 2.5 tall. So then we're going to get the horizontal, and for the horizontal it's going to be length times cosine, so length of 30 times 5, or sorry, cosine of 30 times 5.
That is 4.3301.
Okay, so we'll just say it's 4.33. Okay, so we've got the horizontal, we got the vertical of each of these. And then go ahead and do this one too for the 90 degrees. So do me a favor, do the sine of 90 degrees times 6.
You say sine of 90?
Yeah, sine of 90 times 6.
Alright. And that's 6.
Okay, actually, yeah, I should have. We didn't even need to calculate that. We can just figure it out by looking at the line. Okay, and then the horizontal, actually, for this should also be really straightforward if you look at it. The horizontal is 0. It doesn't move side to side. Okay. So we need Oh, wait. Was I doing this right? I'm trying to remember what the next step was. I'm suddenly drawing a blank. Okay, let me go back to the actual quiz here. Well, you know how to get those at least. Give me a second here.
Right.
Oh, I was facing the wrong way. Let me look at one of the actual problems. Okay, you know what? They don't actually give you any that are specifically like that. They're always at right angles to each other. Okay.
So what the calculations for those will be the same process of what you just showed me, right?
Yeah, you're gonna have other problems where it's gonna give you just a single vector, and it's gonna say what's the horizontal or what's the vertical length of this vector, and you just use these two formulas here. Okay, so they're not gonna give you any questions specifically. There's not gonna be anything like this where you have to add them together.
Okay.
At least not like that. Let me just go ahead and erase this, but that was good for practice anyway. Okay, so the actual problem is more like this, where you're going to have basically two vectors, and they're going to be effectively at a right angle to one another. It doesn't cover anything of how to get vectors added together for other angles, but it's basically going to ask you to do something like you're going to have a vector of 50 and then like a vector of 75, and it wants to know what the resultant is of that. And one thing you can do for vectors like this... Oh, that's right. No, I remember now. You can do it for others. Okay, so basically if you have two vectors like this, what you can do is start with one vector. So you've got your 75 there, and then the other one was 50 going straight up, right?
Right.
What you do is you start at the end of one, and use that as the beginning of your next vector. Like that. So you got 75, 50. What you have now is you've got a right triangle. And so all you need to do, very straightforward, is just use the formula of... Tracking is really bad for some reason, I don't know why. At least in that corner specifically. Remember the a squared plus b squared is equal to c squared?
Right, Pythagorean theorem, right?
Yeah, same thing. Is you can literally just do a squared plus b squared is equal to c squared to figure out what your resultant is. And you can literally take, if you have even if you have like several vectors and they're just going in like weird directions and magnitudes, you can literally do the same thing. You can put them all end to end, and then from there, if you can make some sort of a right triangle, you can then do the calculations and figure out what your resultant is.
Okay.
I think I might need to find a better whiteboard. But yeah, that's pretty much everything, like the important stuff for lesson 2. Just like the key stuff.
Alright.
And those are your three formulas you'll use the most. most likely.
Just bring this down. Well, I appreciate it, Nate.
Uh-huh.
Thank you.
Yeah, welcome. And I'll try and see if I can find something a little more reliable than this. This is like really choppy, and the tracking's getting a little crazy on my hands.
Okay.
But yeah, I'll see if I can do this for the other assignments.
All right.
Yeah.
See you, dude.
All right, later.